I'm Zaibo from Huawei. Today the topic is progress of Warpdrive. This is a Common Accelerator Framework for user space. The topic contours includes looking back and the progress and the example for Warpdrive, and also cover the current challenges and the next step. Firstly, let's look back on Warpdrive on SFO 2017 and Hong Kong 2018. What is Warpdrive? I think the left right of the architecture overview can show you. But right now the name is updated. Warpdrive is called as the kernel part of Warpdrive is called as short domain media devices. And the Warpdrive is now renamed as Warpdrive. And I think this name may be updated in the next also more. An accelerator framework for user space leverage hardware accelerator with native performance. And it also it is based on VFIO and mediated devices. This allowing for direct access hardware with improved security and efficiency. And hardware accelerator is accessed via queue. The queue of the notion of queue is the minimal working unit for user space. The queue's DMA priority is controlled by the user. And Warpdrive can support SVA. It is compatible with Jean-Philippe Brooks' SVA patch set. Dynamic queue allocations mechanism with DMA access supported with multiple processes. Warpdrive is also compatible with other subsystems and support low IMU mode. Low mode MDUV logic is kept, and the native driver can be kept also. Why Warpdrive? We use Warpdrive try to get the native performance of accelerator. Secondly, we try to break the limitation of one device serving only one process with queue. And finally, user space DMA should be controlled under security. Then let's go back then. The status saying SVA from GPB was in the phase of VE. We won. Substring ID was still not supported by SMU driver. And Warpdrive supported multiple processes with SVA enabling. And SVA without I/O page fault running OK on HiSilicon D06 board. The next is Warpdrive Progress. Warpdrive RFC-v2 patch set had been released. And also some updatings on Warpdrive. As third, enhancements of GPB's SVA proposal. Finally, we will show an example Warpdrive SVA on Hasidic D0 board. Okay, let's talk about the RFC patch. The following discussions are ongoing. One, whether WebDriver should go around VFIO, and should we create a chart device and a DMA buffer pool for each accelerator via Java probing? The example is KFD solution from AMD for GPU. Secondly, whether LMU should be aware of mediated device or need auxiliary domain. This is proposed by Intel. I think it's analogous RFC solution on VFL operating mediated device. This is relating to the inter-scalable mode virtualization. Whether resource should be pre-assigned as the MDUV be created. This try to be similar to original VM scenario of MDUV. What's more, whether an accelerator device should be shared between user and kernel node. All right, all the above four topics are discussed. In the next, I will talk about some updatings on WebDriver. Firstly, mediated devices aspect. Currently, the mediated devices are created by root, the root permission, before Warpdrive processes start. And they are also destroyed by the root after Warpdrive process end. Queues are held by a process are released automatically if the process exceeds unexpected. Path ID setting logic is moved from user space to the VFIO core. You know, the GPB's patch set, in the GPB's patch set, the path ID is exposed to the user space, and the path ID setting logic is carried out by user space driver. The fourth, resources are pre-assigned at MDUV creation. This updating is based on the Alex Williamson's advices. We also do some enhancements of GPB's SVA proposal. Firstly, path ID is not exposed to user space. I think this is for security. Secondly, VFL attach and detach commands operate on the LMU group of MDUV's parent device. I think this is the core logic of Warpdriver. 3. We enable user space DMA mapping from multiple processes by creating private IO page tables. 4. We try to break the limitation of SVA using scenario of primary and secondary processes. You know, the GPB's SVA patch set using scenario is including primary and secondary processes. He tried to detect all the devices from VFL PCI and get the device information by the primary processes. And then I think the secondary processes try to get all the device from the primary process. And the primary process try to band the device for the secondary process, expand the address space of the secondary processes. Finally, we try to keep all the user APIs of VFL unchanged when enabling SVA. Then I think this is an extra topic. Why GPB's SVA using scenario is not general. Overall, I think GPB is trying to be compatible with VFL PCI. I think for standard thing, he has no other way to go. He need to expose pass ID to user space, and he has to lay out his user space processes as a primary and a secondary process as DBDK or something like ODP. I think this is not general for a general scenario of user space. And more, banned and unbanned IO control commands are not general APIs of VFIO. They are added by GPB. Okay, let's come to talk about the example. We have do some SVA test on our D06 board. It's running on SVA store mode. We are based on GPB's SVA v2 patch set. However, we used pseudo PCI device, the zip accelerator, which is for data compression and decompression. And planned for device store mode is running on zip. Maybe you would ask me, this is a PCI device, why you are running the store mode? In the next, I will answer this question. The fourth attribution, the fourth feature is we can run multiple processes of SVO. Of SVA. So why we are running SVA store mode in PCI devices? I think this because the hardware condition limitation. Because right now the zip PCI devices has no ATC, and also PRI I think is not working now. So one question: should the store mode be supported as a common mode for pseudo PCI and planned for devices? I'm also not sure. And this is the performance of the SVA scenario. The blue one is SVA without IO page fault. This check by calling mlock to pre-page fault to do pre-page fault, and the red one is multiple mapping by the private page table of devices, and the gray one is SVA IO page fault scenario. This is one process with one queue scenario. And the function API is in synchronous mode. I don't know, this finger has some mistake. I don't know when I copy from my laptop this drawing, you know, the category. I don't know how they come. Actually, this is the packet length from 128 bytes to 8,000 bytes length, the packet length. And the throughput is million PPS. This scenario is running 3 processes with 3 queues. Okay, let's talk about the current challenges. The first one is Warpdriver maybe still existing security risk since several users work on one devices, because I think also this is the hardware cannot solve this problem right now. It is not isolated as much as a task or a VF. Secondly, I think coexisting with Linux kernel, crypto, AF, ALG, something like this. This is a controversial topic, I think. However, ecosystem is ready because devices support pass ID, PRI, ATC, and the corresponding software such as VFL and SVA is also in place. What's more, user space should be able to leverage the accelerator directly with high performance. And not that device can DMA from user space in a fast and secure way. Finally, I think this is also the main problems for Warpdriver. This is because the IOMU and the VFL software status is, is pending. No fixed solution on pass ID and the IOMU domain, because we are also discussing whether we need a multiple domain or parent domain or children domain or something like that. We are not fixed. Okay, next is plans. And we have Warpdriver RFCv3 will be released shortly, and Intel's work on IOMU award medium device will be taken into account. And a general solution for using SVA based on VFL Warpdriver will be brought up. Finally, I think more work will be done on user space Warpdriver. I think there will be much work to do. Okay, that's all. Thank you.
So I have a whole bunch of questions, but just to start the basic ones. Is this work under the guise of some open source foundation or project, or is this just something that's being proposed? Like what's the, is it open to other companies to participate in this? How is this structured, this whole project structured?
This project is, we try to be open, and we try to be a general solution for user space devices, for user space scenario for devices.
So is this actually run by a Linaro SIG or group?
Sorry?
Is this project run through a Linaro SIG or group, the Warpdrive, or is it all done by Huawei, or how is it run? Is it actually got weekly calls? Has it got a Linaro project manager? Is it run by somebody else? Or is this purely a Huawei thing? Who's running the project?
We are running the project.
Huawei.
Yeah.
Okay, so it's not part of Linaro then? Yet.
In the last Connect, we talk about the cooperation with ODP.
Okay.
Because I think this is also working for the NIC card for user space.
Right.
Yeah.
The proposal he's making, I think it's on the Linux mailing list, so they're not doing it, behind closed doors within Huawei. It's like Huawei engineers proposing a solution on the public Linux mailing list. It's kind of happening in the open, in the Linux kernel development community.
But you also mentioned that it could be part of, or brought into ODP as a part of an ODP enhancement to the ODP project. Did you mention that? Is that going to happen soon, or are you going to bring that to the ODP committee?
I think it's hard to say, because we should try to solve the problems of accelerator. Then maybe the network is in the next.
So for the accelerator, one thing I didn't really tell, I was hoping to get more on, is what is the fundamental architecture of the warp driver? You talked about the queues. Are these queues sort of like traditional ring queues, like an Ethernet driver would have, or are they more like InfiniBand, queue pairs with doorbells? What's the actual structure of how the user would actually interact with the device?
Actually, currently the queues is the hardware queues. We just expose the hardware address information to user space by median devices logicals. I don't know,
the queues are not structures in memory. They're not memory structures of pages and stuff in memory that the user space reads and writes to. They're actually, you're writing right to the queue itself, you're saying? If I want to submit a request, the queue is actually inside of the device, and I'm actually writing MMIO accesses to add things or remove things from the queue?
Sorry?
The queuing, where are the physical queue descriptors? Are they actually in regular memory, or are the queues implemented totally inside of the actual accelerator device?
Sorry, I cannot hear clearly.
Is it hardware or software queue implementation? Is it done in the SoC? You have some IP providing support for it, or it's completely software?
I think it can be completely software, but right now, one Warpdriver queue is corresponding to one hardware queue. But yeah, but we can also do multiple hardware queues for one software queue. It's also case supported.
So when software, user-space software wants to send in a request to an accelerator, does it have to write first the memory for where it wants the data to be, then it has to write the queue, the request, command that it wants done, and then hit some doorbell or something to tell the hardware that there's some new entry, or what's the process for software to actually send off a zip command, for example?
We just try to, the doorbell or something like that to user space. And we have a user space driver under the user space warp driver.
Well, yeah, but you'd hope that you don't need a driver. I would hope you could just have a user space program, just call a library and directly talk to the queue on the hardware without having to talk indirectly through some indirect driver or something, no? Is the complexity of this queue so large that you need to have a whole driver to actually do it, or are we just talking about the ability, couldn't I just directly write to the queue and myself and have it kick off something?
The web drivers supply the queue allocation APIs for user to get queue or put queue.
Creating a queue or putting a queue element? When you say an allocation, are you talking about allocating queues or allocating an entry in the queue?
We can allocate a queue handle. This is a software notion, and from the queue you can send the accelerator message or get the responding message from the queue. Actually, because this is the I didn't talk the the API of Warpdrive because we have a two presentation in the next two Connect. So this is it's not so detailed.
And does this architecture allow responses out of order? So if I send in a bunch of requests to an accelerator, can the replies come back ordered or unordered or both? What's the rules for the replies?
I think order and out order, maybe it's the software lawyer up Warpdriver. We just supply the sending and the receiving APIs. Maybe you.
But those APIs, do they require the replies to come in order, in the same order as the requests, or can they come up back in a different order? Does the API allow them Does the API allow reordering of the replies or not?
Warpdrive don't care the order because the message comes, then you can receive the message. I don't care the order or out order. Yeah, you just a channel between user space process and the hardware. Okay, thank you. So, any other question? Okay, maybe this time.